Hey guys, so today we're going to be continuing talking about the parent functions, but today specifically we're going to take what seems like a little bit of a break from that because it's going to help us with what we need to do next. So we're going to be talking about function notation. So in Algebra 2 we're going to use function notation when we write functions, so this is going to replace writing y equals like we're used to seeing. So instead of writing y, we're going to use our function notation, which is going to be f of x, and that's how we say it. It's the letter f with parentheses and then the letter x. And we say f of x. It doesn't always have to be the letter f. It could be the letter G or Q or whatever letter you want in front. That letter is just telling us that we have a function. So what f of x means is that we have the function f, or whatever that first letter is, with respect to x. So we have a function f with respect to x. And I don't know why it auto-capitalized that for me, but since it's a lowercase f, it would be a lowercase f here. So let me see if I can fix that. There we go, the function f with respect to x. So it's telling us that we have a function, and then the variable is the x. So whatever's in the parentheses is the variable. So if we put something else in the parentheses, that's what we have to replace the variable with when we're using function notation. So for example, when we're talking about whatever in the parentheses replaces the variable, we have an example here, f of x equals 4x minus 5. If that's the case, then f of x plus 3 equals 4 times x plus 3 minus 5. So notice here, when x was in the parentheses, x was the only variable, right there. But when we have x plus 3 in the parentheses, then we go back to wherever the original variable was in our function, so where there was an x here, and we replace it with x plus 3. So we replace the variable with whatever is in the parentheses. All right, so we have several examples that we're going to go through. So we want to evaluate each of the functions at the given value. So first of all, we have the function f of x equals the absolute value of 3x minus 4. All right, so that's going to be example 1. F of x equals the absolute value of 3x minus 4. I'm sorry if it's a little blurry. My camera's having a hard time focusing on the paper. And we want to find f of negative 2. So to do that, we take our negative 2, and anywhere we see an x in the original function, we're going to replace it with negative 2. So we had absolute value of 3 times x. Well, instead of x now, we're replacing it with that negative 2. So 3 times negative 2, close the absolute value, minus 4. So you can see here that that negative 2 replaced x from the original function. Then we need to simplify. So we use our order of operations, parentheses, exponents, multiplication and division, addition and subtraction. So inside our absolute value, we have some multiplication. 3 times negative 2 would be negative 6. So we have the absolute value of negative 6 minus 4. Next, you may have to think back a little bit about this, but absolute value of negative 6 is just how far 6 is from 0 on a number line. So basically, it just takes the number and makes it positive. So absolute value of negative 6 is positive 6. We bring down the minus 4. And then finally, we can subtract. 6 minus 4 gives us 2. So f of negative 2 equals 2. Okay, let's look at our second example. So for our second example over here on our notes, we have f of x equals negative x squared plus 4x. And we're being asked to find f of 3. So if I write that over here in my notes, I've got f of x equals negative x squared plus 4x. So if we go to find f of 3, again, we're going to take this 3 and we're going to plug it into our equation anywhere we had an x. So we're going to plug it into the first x and into the other x. So anytime there's an x, it gets replaced with whatever is inside of our function notation. So when we do that, we had negative x, that's going to change to negative 3. Notice the negative that was in front of the x stays with the 3 when we plug in 3. So negative 3 squared plus 4 times x is going to change into 4 times 3 when we plug in the 3. Then we can go through and simplify. So We would do whatever's in parentheses. Well, the only thing in parentheses are individual numbers. Next, we get to exponents. So negative 3 squared is the same as negative 3 times negative 3, which would give us a positive 9, plus 4 times 3. Next, we would multiply 4 times 3, so 9 plus 4 times 3, well, 4 times 3 is 12. And finally, we're going to add together 9 plus 12, and 9 plus 12 is going to give us 21. You may want to check me on that. I'm doing it on the spot. But f of 3 should equal 21. All right? And then we've got one more example on this page, then we're going to have some more examples on the next page. I'm going to try and leave that one on the screen in case you're still trying to get your notes. If you're struggling, you can always pause the video and come back. All right, next we have f of x equals 2x cubed minus 3x. So that's coming from over here, 2x cubed minus 3x. And this time we're not plugging in a number. We're plugging in a change to the variable. So up here we had a number that we plugged in and then we simplified and got a number as our answer. This time we're just slightly changing what's happening with our variable. So we have f of x minus 4. We still follow the same pattern. We're going to plug in x minus 4 everywhere we had an x in the original equation. So we still have 2, but instead of x cubed, we plug in x minus 4. So when we do that, we're going to plug it in parentheses because that 2 is multiplied by the x. Well, replacing x is x minus 4. So that 2 doesn't just need to be multiplied by one part of this expression, it's multiplied by the entire thing. Same thing, x was cubed. When we replace x with x minus 4, the entire thing needs to be cubed. So we keep it in parentheses, and then we can go through and simplify if needed. And then minus 3 times, again, we're replacing x with x minus 4, so 3 times in parentheses x minus 4. All right, and later in the year, we're going to go through and talk about how to break this down and simplify it, but for right now, that's where we're going to leave it. So then this would be our answer for now. All right, let's look at a few more examples. So these ones just add in a few more operations. Some of them are going to get a little bit complicated, but we're again going to evaluate the functions using the function notation that's shown to us. So let me go ahead and box in that last answer. All right, so next, our next example, we have f of x equals the absolute value of x plus 4, and we want to know what is f of x minus 3. So notice now we're not plugging something in for x because the number isn't in the parentheses. The only time we're plugging in is when that number is inside the parentheses. Now we're changing something outside of the parentheses, so it's not changing what we plug in, but it is going to change our function. So if f of x is absolute value of x plus 4, and we want to do f of x minus 3, to do that, we're going to bring down f of x. So we're going to plug in absolute value of x plus 4 in for f of x, because those are still equal to each other. So we have absolute value of x plus 4, and then we just have minus 3 tagged on at the end. So again, here we have f of x, and then we just add minus 3 to the end. So then if we go through and simplify, we can do 4 minus 3. 4 minus 3 is 1. So we get the absolute value of x plus 1. And that would be f of x minus 3. Okay. Next, we have f of x equals negative 3x squared plus 1. And we want to know what happens when we do negative 2 times f of x. So again, the change this time isn't happening inside the function. It's not changing our variable. This time it's happening on the outside of the function. So that means it's happening to the entire function as a whole. So we're going to do negative 2 times something, and we're multiplying times f of x. So when I go to multiply, I'm multiplying times negative 3x squared plus 1. So that's what I'm going to bring down into my parentheses to be multiplied by. Then I can close off my parentheses. So right here we have our f of x. So negative 2 times the underlined statement is f of x. All right, and then this we could simplify by distributing that negative 2. So if we do that, negative 2 times negative 3 gives us positive 6, and we would just bring down the x squared. And then negative 2 times 1 would give us negative 2. So we get 6x squared minus 2 when we do negative 2 times f of x for this function. All right, for our next example, we have f of x equals negative 3x squared plus 1. Oh, that's the example we just did. Just ignore that part. Don't do the same example all over again. I mean, you can. Hopefully you get the same answer. Our last example actually is f of x equals log base 2 of x. And now this one's complicated. I threw a whole lot at you because I just wanted you to see how complicated it can get. We have 4 times f of negative x minus 2 plus 7. All right, this one's going to get kind of tricky. All right, I don't expect you all to be able to do this on your first try. So, several things that are going to happen here. We have things happening on the outside of our function and things happening on the inside of our function. So the first thing I'm going to do is I'm going to plug in my new variable. So where I have an x, I'm going to replace it with negative x minus 2. So we get log base 2 of negative x minus 2. All right, so I plugged in my new variable. I plugged in what was inside of my function. Now I have to make the changes to the outside of the function. So we've got multiplication and addition. And if we think about order of operations, we always do multiplication before we do addition or subtraction. So when we do our multiplication, I'm going to multiply 4 times log base 2 of negative x minus 2. And you can put the log in parentheses if you want to, but actually putting the 4 right in front is multiplying by this entire logarithm. And we haven't talked about logarithms yet, so I don't expect you to be able to figure that out. But if you want to, you can always put it in parentheses, but you don't have to. And then at the end, we have plus 7. All right, so we throw the plus 7 at the end after we do our multiplication. And this right here would be the simplified version. Well, not the simplified version, but a version of our function. So this is what we get when we do 4 times f of negative x minus 2 plus 7. And I know it looks weird, but that's what we get. And that's going to help us set up for tomorrow and the day after that, because we're going to be doing transformations of functions, and we're going to see equations that have a lot of this kind of stuff happening, but it's not going to be as complicated as trying to rewrite it all. All right, let me know if you've got any questions. I know I kind of threw a lot at you here at the beginning, and have a great day, you guys.